Hello students, welcome to the classroom point. In today's session, we shall discuss the rest of the questions. Question number 11. Here one question is given. The reactant molecule double bond is not properly visible. I will write down here. This is the molecule on reaction with HBr gives what type of the molecule? It is simple Markovnikov's addition reaction. H plus N preferably attacks over the carbon with a more number of hydrogens, and bromine will go and attack with the carbon with a less number of hydrogens. And here no rearrangement. Why? Because itself it gives the stable tertiary carbocation, so that the product will be this one. So option B is correct. 12th question. The same molecule is given, but with in the presence of the peroxide they had given. So just I will take this one only. Again HBr, R2O2 peroxide. So in the presence of the peroxide, anti-Markovnikov's addition takes place, so that bromine will go here and H plus N will come and attack in this particular place. So we get the molecule of this one. Hence option A is correct. Now let us see the 13th question. In this 13th question, the given reactant molecule, this is the one which reacts with the HCl. So they are asking what type of the product actually be formed. So according to the Markovnikov's addition, initially H plus N will attack over the carbon with more number of hydrogens, so that we get this stable secondary carbocation. But there is a chance for the formation of the next one more carbocation if this H plus N is hydrogen is completely transferred, so that here 1,2 hydride shift takes place. So hence we get the stable carbocation at this place, that is tertiary carbocation, so that Cl minus attacks over this particular place and provides the molecule this one. So option C is correct. Now let us see the 14th question. So in this 14th question, the given molecule is CH double bond CH. So one side of the double bonded carbon is having the benzene group, other side cyclohexane molecule, cyclohexane part. So HBr. Now this H plus and Br minus, H plus can attack either this place or this place. So I will take the two possibilities here. So possibility 1, imagine that H plus are attacking over here and giving positive charge at this particular position. CH plus CH2 cyclohexyl part. And imagine if H plus N is attacking at this particular position, then second possibility is CH2, CH plus and the cyclohexyl group. And interestingly, both are secondary carbocations only, but this is a secondary benzyl carbocation. So secondary benzyl carbocation is more stable than the normal carbocation. So hence this H plus N preferably attacks over here and to produce this stable secondary benzyl carbocation. Later this Br minus attacks at this particular position here, so that the final product becomes CH, Br, CH2, and this is the final compound. So option A is correct for the 14th one. Now let us solve the question number 15. So in question number 15, again same product is the same reactant molecule is given, but conditions are changed. HBr and peroxide. So in the presence of the peroxide, opposite Markovnikov's addition takes place, so that we get the product CH2 CHBr, and this is the molecule, hence option B is correct. Here I need to discuss one important thing regarding the Markovnikov's rule and anti-Markovnikov's rule, so that I'll explain here only to small extent. I'll take the general example, like everybody takes propene molecule. The important thing in the Markovnikov's rule and anti-Markovnikov's rule is, if you take H plus and Br minus, this is Markovnikov's rule. So H plus ion preferably attacks over the carbon with more number of hydrogens or less number of the substituents in order to provide the stable carbocation like this. But if the same HBr is used in the presence of the peroxide, you must observe that this, whatever the peroxide radical is there, that combines with the HBr, and here homolytic cleavage of the hydrogen bromine bond takes place, and this peroxide radical preferably takes up this hydrogen and forms alcohol, so that we are having the Br bromine radical. So in Markovnikov's rule, H plus ion attacks, but in anti-Markovnikov's rule, bromine free radical means halogen free radical preferably attacks. So if halogen free radical attacks this particular place and this particular place, means two chances are there again here, attacking at the first carbon or attacking on the second carbon. If it is attacking on the first carbon, it provides CH2Br, this is secondary radical, and if it attacks over the second carbon, it provides primary radical. Secondary radical is stable, hence bromine radical preferably attacks over the carbon with more number of hydrogens. So that is the reason why here also bromine radical preferably attacks over this particular position to provide benzyl secondary free radical, which is more stable, and we are getting this particular product. Let us solve the question number 16. Arrange in decreasing order of reactivity with HCl. It is simple thing that all these molecules are having one unsaturated side alkene part. So their reactivity is HCl is only with, HCl combines with only this particular part, means it is indirectly reactivity of the alkenes. So alkenes reactivity, alkenes means reactivity here. So reactivity alkenes is directly proportional to the number of electron donating groups. If electron donating groups increases, reactivity of the alkenes also increases. So here electron donating group is there, so that third compound is more reactive than the second compound, which is more reactive than the first compound where electron withdrawing group is there. If electron withdrawing group is there, it will withdraw the pi electrons towards its side, so that these pi electrons will not be available for the addition reactions. So that is the reason why alkenes are more reactive towards the addition reactions when there is a more electron releasing groups. Okay, so option B is correct for this. Now let us solve the question number 17. So in this question number 17, the given molecule is CF3CH double bond CH2 with HCl. So H plus ion can attack either this position or this position. You see that if H plus ion attacks over the first position, that is the first position, here this is the second position. So if attacks over the first position, then we get the CF3CH plus CH3. If attacks over the second position, then we get the CF3CH2 plus. Now we need to see both of these carbocation. This is the secondary, this is the primary. But this is the one which is stable, though it is the primary carbocation. The reason is here the secondary carbocation is added to the connected with the electron withdrawing groups. So the presence of electron withdrawing groups destabilize the carbocations, means still they increase the positive charge. So once positive charge increases, the molecule becomes unstable and ready to participate in the reaction to reduce its positive charge. So that's why this H plus ion preferably attacks over this position, giving this better carbocation. So this one on reaction with this Cl minus ion later, so gives the CF3, CH2, CH2, Cl. This is the product, hence option D is correct. Let us solve the question number 18. Give the major product obtained from the reaction of the following with HBr. So this molecule with HBr they are asked. So let's take CH2, HBr. Simple Markovnikov's rules, H plus ion preferably attacks over here and to produce the stable tertiary carbocation like this. CH3 and positive charge, this is a tertiary carbocation and stable. This one on reaction with the Br minus attacks over this position and produces this molecule. Hence option B is correct. Dear students, hope you like my explanation. If you like, please share this video to your friends, subscribe channel, comment whatever you feel about this channel, and do not forget to like this. Thank you one and all.